So the question reads, suppose the seller of a chitenge material wants to lower the price of chitenge from 150 kwacha per meter to 142.5 kwacha per meter. If current sales are 2000 meters per month and the price elasticity demand of the product is zero point 0.7, show number one, whether or not his total revenue will increase after lowering the price. Number two, calculate the exact magnitude of its new total revenue. All right. So basically here, for the first one, it's saying whether or not his revenue will increase after lowering the price. So the answer for this one is this. Whenever demand is inelastic, I believe we remember what inelastic demand is, right? Colleagues, what is inelastic demand? Whenever demand is inelastic, if you reduce the price, the total revenue is also going to reduce. Now, I was asking, what is inelastic demand? And how do we know if demand is inelastic? There's Mr. Vincent, Mr. Twambu. You're now quiet. What does it mean when demand is inelastic? Yes, it's not sensitive to changes. So in this case, this is demand is inelastic. So quantity demanded doesn't respond greatly to changes in price. Okay? And due to this fact that quantity demanded doesn't respond greatly to changes in price, okay, that's why usually with your total revenue, if you reduce the price, total revenue go down. If you increase the price, total revenue is also going to go up due to the dynamics of inelastic demand. Okay, the percent change in the quantity demanded is usually is less than the percent change in price. Price can increase or decrease by a big amount. Quantity demanded is not going to, it will increase by a lesser amount. And due to this fact, that's why when you reduce the price, the total revenue goes down. And when you increase the price, total revenue will go up. So even with this example, we are going to show that when this person reduces the price, indeed, the total revenue is going to go down. Okay, this is because quantity demanded changes small. There's change in quantity demanded is less than the change in price because quantity demanded is not responsive to changes in price. It's not very responsive. Okay, and in this question, they've told us our price elasticity of demand is zero point 0.7. When your price elasticity of demand is less than 1, then you know that demand is inelastic. If your price elasticity of demand is greater than 1, then demand is elastic. Are we clear with that, colleagues? Any questions? Okay, so now we need to show this exact, we need to find out this new total revenue. Okay, so they've told us he's charging 150 kwacha per meter. So this is going to be our P1. The current sales are 2,000 per meter. So this will be our Q1. Now he wants to reduce the price to 142.5 per meter. So this is going to be our P2, 142.5. And then we need to find what would be the new quantity. So let me just do the tabulations here. So we use this same formula for price elasticity of demand. We just zoom out. Yes, so price elasticity of demand equals percent change in quantity demanded percent change in quantity demanded divided by percent change in price. So we already have our price elasticity of demand. It's 0.7. Now that's the absolute value. Okay. Colleagues, why did I say we need to include this 0.7 here? Does anyone remember here? This negative, why I've included the negative? Due to the law of demand, which we say that when price goes up, quantity goes down, or when price goes down, quantity goes up. Due to that inverse relationship between price and quantity demanded, whenever you're always calculating the price elasticity of demand, you always be getting a negative value. Okay, because one of the percent changes is going to be dropping and it will give you a negative percent change. All right, so that's why whenever you're calculating price elasticity of demand, the final answer you get the absolute value, because if you don't get the absolute value, all the time your answers will be negative, and negative is always less than 1. So it will be meaning each time you calculate, you always be getting inelastic demand. So your final answer, you have to get the absolute value so that you can interpret whether it's inelastic or elastic. So in this question here, since they told us the price elasticity of demand is 0.7, that's the absolute value. Now here, when we're calculating the percent change for price, we need to include this negative, which was ignored in getting the absolute value. Yes, do you want to say something? Oh, no, I haven't yet gone there. I'm just explaining why this negative is here. Yes. I think, yeah, I'm done with the explanation. Yeah. So even when we're doing this calculation here, if you ignore this negative sign, what you find that for your quantity demanded, because in this case price has gone down, so quantity demanded has to go up. So in this question here, if you ignore this negative value, you also find that your quantity demanded is going to go down and you'll be going against the law of demand. So here in this question, we can only get the price, percent change in price, because we've been given P1 and P2. Okay. So to get the percent change in price, you can use the P2 minus P1 divided by P1 times 100, new minus old divided by old times 100, right? Or you can use this formula P2 divided by P1 minus 1, new divided by old, you still get the same percent change, okay? Times 100 also here, times 100%. So in our question, our P2 is 142.5. Our P1 is 150. So 142.5 divided by 150. That is 0.95. 0.95 minus 1, negative 0.05. Okay. So if we want, we can still put this negative 0.05 here. So when we multiply it with the price elasticity of demand, we'll still get a decimal. Then we can convert it into a percentage. That's one way you can do it. Or if you want, you can convert this 0.05 into a percentage right now by multiplying by 100. You get negative 5%. So price has dropped by 5%. So we just substitute here and put negative 5%. So we want to find the percent change in quantity demanded. So you just cross multiply. Negative 5 times negative 0.7. That will give you 3.5%, positive 3.5%. So price has dropped by 5%, quantity demanded has increased by 3.5%. Okay. So our Q1 was 2,000 meters. And we've said price has increased by 3.5%. So we need to increase this 2,000 meters by 3.5%. So to get that 3.5% increment, you just multiply this 2,000 by 1 plus 0.035. The other way you can do it, just find 3.5% of 2,000, you get that value, then add it to the 2,000. That's the normal way of doing it. Okay, you just get 3.5% of 2,000, get that value and add it to 2,000. But the other way you can do it is like this: multiply 2,000 times 1.035 basically. So 2000 times 1.305 gives us 2070. So this is our new Q2. Yes, so our new quantity is 2070. Any questions? So the question says calculate the magnitude of this total revenue. So we just say total revenue 2 equals P2 times Q2 142.5 times 2070. You get 294,904. This is the new revenue. Now we have to show that, I just want to illustrate to you that this revenue has dropped because before the price change, this was the original revenue. If you call TR1, P1 times Q1, the original price was 150 and the original quantity was 2000. So 150 times 2000, you get 300,000. Okay. So as we stated earlier in the first part of the question, that when demand is inelastic, when you reduce the price, total revenue will also reduce. And in this case, this person reduced the price to 142.5 and the total revenue dropped from 300,000 to 294,000. Yes. Any questions? If there are no questions, we can go to part, let's see, so it's part 1 and 2. Part B of the question. Quick question B, but B is saying the following demand function for ready-made trousers has been estimated. Q equals 2000 plus 15y minus negative 5.5p, where y is income, q is quantity demanded, and p is the price per unit. So when when p equals 150 and y equals 15, determine the price elasticity of demand and the income elasticity of demand. Okay, so price elasticity of demand, how quantity demanded responds to changes in price. Income elasticity of demand is how quantity demanded responds to changes in income. Okay, so the first thing you need to do for this type of question, since you've been given the price and the income, first we have to find Q. Okay, we have to find the actual quantity demanded. That's what is represented by Q, the actual quantity demanded. So we just do our substitutions first. It's 2000 here plus 15. So y substituted with 15 here plus, minus 5.5. P substituted with 150. Colleagues, let's get our calculators so that we get our answer here. 2000 plus 15 times 15 minus 5.5 times 150. What do we get? I'm getting 1400. So I confirm. I want you to confirm. Are we all getting 1400? Are we all getting 1400? What about Mr. Dennis? Okay, yes, Madam Sarah. Okay, Madam Geraldine, Madam Florence, Mr. Vincent. Okay. Okay, so now first we get price elasticity of demand. So here, notice with this question, there is no P2 and a Q2. You've only been given just one price and you have tabulated only one quantity. So in this case here, this is how you get your price elasticity of demand. Because here, there's no percent change that you can calculate. So you see price elasticity of demand equals yes. So here, this is the partial derivative of the quantity function with respect to price. What basically this is saying is you're going to derive this quantity function here. And you're only going to focus on p as the variable. If any number doesn't have a p attached to it, it disappears. Okay? Then you multiply this times the price over the quantity. So we need to get the partial derivative of our quantity function. So as I said, if anything doesn't have a p, it disappears. Okay, so here we've got negative 5.5p. So you take this as p to the power 1. Then you derive. When we're deriving, multiply the exponent with the coefficient. 1 times negative 5.5, you get negative 5.5. Okay, then you subtract a 1 from the exponent here. So 1 minus 1, that is 0. So p to the power 0 is just the same as 1. All right, so we've derived our quantity function here, negative 5.5. Any questions? Partial differentiation occurs when a function has got more than two variables. Okay, so in this function here, we've got two variables here. We've got a y and a p. So with partial differentiation, you're going to focus on one variable and ignore the other variable. So here, we're partially deriving our quantity function with respect to p, meaning we're only focusing on the numbers that have a p with them. Those are the ones that we're going to derive. Okay, we're only focusing on numbers with a p. Those are the ones that we'll derive. If a number doesn't have a p, it won't be derived. It will be removed just. So in this function here, there's only one number with a p, and that's this negative 5.5. So that's the only number you're going to derive in the function. Is that okay, sir? Do you remember how to differentiate? When deriving, only the power you always subtract it by 1. That's differentiation for calculus. In calculus. Okay. The power always subtracted by 1. And since this p is just by itself, so it is p to the power 1. So are you confused with the calculus or the concept? Or by everything? Okay. Yes. Okay. But the concept is this. When you have okay, Mr. Trumbo, just hold on. When you have an equation with a lot of letters, then you know, and you have to derive that equation. That's when you're going to use partial differentiation. Okay. If the equation has got just one letter, you don't need to do partial differentiation. But when there are many letters, partial differentiation comes in. And the key to partial differentiation is you're only going to focus on one variable and eliminate the other variables. Variables, I'm just talking about letters. Okay. Yes, Mr. Twamp. Okay, let's start with the easiest one here. If it was power 3, you would have done 3 times negative 5.5. And then that same power 3, you subtract a 1 from it. So you would have got, when you multiply 3 by 5.5, I think negative 16 point something, 17, p to the power 2. Okay. If you had, that's what would have happened if you had a p to the power 3. Okay. If you had a p with this y here, you would have still also differentiated. If it was like this 15 py, you would have still differentiated. You would say this is p to the power 1. You multiply this p here, this 1 times 15, and you subtract from that p, and you'd have remained with a 15y. Okay, Mr. Twambo. But weren't you there now when we were doing differentiation last time in maths? How many were there during differentiation that time? Most of us were there. Yes. Okay, so here you put negative 5.5. The price is 150p. The quantity is, we got what quantity? 1,400. So what is 150 divided by 1,400? What is 150 divided by 1,400? Mm, Yes. Okay. Mm-hmm. Mm-hmm. This is what has happened here. This is what has happened here. It's the p to the power 1. We subtracted the 1 from it, madam. So that's how it remained as p to the power 0. Okay. When you're deriving, once you've multiplied the power with the number in front of the letter, go to the coefficient. You always subtract a 1 from that power. Always, okay? Always. So here when you subtract 1 minus 1, it remains as p to the power 0. Yes, which is the same as 1. That's why we have oh, okay. Where were we? What is 150 divided by 1,400? Okay. Actually, let me even be putting it in words so that those who are waiting for it to be typed, it's coming in. So let's see. And then when you multiply that by negative 5.5, what do we get when multiplied by negative 5.5? I'm getting 0.589. Negative 0.589. So we get the absolute value. Okay. Because if you don't get the absolute value, as I said, every time, then it means demand will be inelastic all the time inelastic. Okay. So absolute value, so it's 0.58. 0.58. So what can we say about the demand? Is it elastic or inelastic? Yes. Yes, it's inelastic. Any questions, colleagues? Okay. We can now get the income elasticity of demand. So income elasticity of demand, YED, okay. Okay, so income elasticity of demand, we're going to partially derive the quantity function with respect now to Y. Meaning, we are only going to focus on the Y variable. Any number that doesn't have a Y disappears. So, colleagues, can we try? What will we get when we partially differentiate? Partially differentiate the quantity function. Mm-hmm. That's correct. Colleagues, yes. So I've seen that it's not difficult, right? Mm. It's yes. If you have that one, you just call me, okay? Yes, just call me on the exam day, Mr. Tuam, okay? Yes, you just say I need to use the restroom. Bah, you go. Bah, sir. It has come. It has come. Okay. I'll try to see if the other questions where this like this. I'll try to make other questions so we can practice. Okay. Yes. Just remember, if there's a P and the Y, the P and the Y are married. You will still do the same way I've just differentiated here. Same way. Like for example, since here there was just a Y, but if there was a P, your answer would have been 15p when you differentiate. The answer would have just been 15p. Okay, then we'll have to multiply that. Was there another question before Mr. Twambos? And are we all okay with how we got this 15? Are we all okay? If you're not okay, you can say, Asa, me, I'm still lost. Don't know how we got that 15. Okay, so when multiplied by the income over the quantity, so you're going to say, mhm, the question says the price was how much? The price P was 150. Y is 15. So 15 divided by 1,400 times 15. So what's 15 divided by 1,400? Okay, 0.0107. Okay. Multiply that by 15. 0.160. Yes. So, since our income elasticity of demand is positive, this is a normal good. Okay. Just hold on for me. Okay, yeah. So, what is a normal good? What is a normal good? So, we haven't been studying normal good, so we have forgotten what a normal good is. Am I right to assume that? Mr. Twambo, am I right to assume that? Sir, haven't been reading economics, so I've forgotten what a normal good is. Mr. Vincent, is it okay to assume that? So, Mr. Dennis, I've forgotten what normal goods are. Mm, yes, yes, a normal, yes. Mr. Vincent, you are supposed to, that's your line. You're always, you're the one who's been always telling us when everything else remains constant. Mm. Yes, that's correct. What you, Mr. Twamba, and Madam Geraldine have said, all of you are correct. When your income increases, you buy more of this good. That's a normal good. And there are a lot of examples of normal goods. Okay? Mini meal, when your income increases, you'll be buying more bags of mini meal for the house. Tea, when your income increases, you buy more tea bags for the house. Then we have inferior goods. What is an inferior good? So we haven't been reading economics in depth like that. So yes. Can you give me an example of an inferior good? An inferior good, an example. Well, it's unfair to call things inferior. It's really hard. Okay, inferior goods is really hard to give examples because you might say good and it becomes offensive to someone who eats that good. So maybe the best kachas was an inferior good. When your income increases, you're no longer buying kachas. I don't think anyone will be offended by that. Yes. So those are inferior goods. When your income increases, you buy less. Okay. Okay, so when the YED, the income elasticity of demand, is negative, then you're dealing with an inferior good. Okay. That's how you interpret for income elasticity of demand. So, any questions before we go to question three, which is on the consumer theory, budget constraint lines, a topic which I've also taught. Mr. Twambo was there, Mr. Vincent was there, Madam Florence was there. So I even know it. That topic will go easy, smooth sailing. So that one boy will be my co-presenter, right? I'll just beam the board and you start explaining with the graphs. You then start doing the deriving of the equations. Okay, yes. So any questions on this before we go to consumer budget, consumer theory, budget constraint lines? Okay, we're now on consumer theory because remember, in economics we said it's all about making decisions with scarce resources. Okay, so even here now in the consumer theory is how you as a consumer make decisions with your scarce resources. And the most scarce resource is money in this case. Okay, we go through this every day. Every time you go to the supermarkets to buy goods, you have a budget and you don't want to go over the budget. Sometimes you have even no choice. You can't even go over it if you want. Others, if things get more expensive, you can increase your budget. Okay. But here in consumer theory, the assumption is you've got a fixed budget and you can buy only two goods. Okay. Yeah. So colleagues, what factors affect what we buy? When you go into ShopRite and you see the price of sausage has increased from 60 to 90 kwacha, what are the factors that affect what we buy as a consumer? All of us go shopping. Obviously, went shopping today. And these factors, it's what you're thinking, colleagues. So please don't feel shy to say it. It's what you are thinking there. It's nothing else. It's the same factors you're thinking of. Uh, the price of the goods, yes. Yes, price of the goods. What else? Hmm. You're getting too technical, sir. But okay, yeah, that can be. We'll add that one. We'll put it on the shelf for now. But that can. But the one I'm looking for is also your income and also your preferences. Okay, the price of the goods, your income or your budget, and your preferences. Okay, so even we can add that fourth one now. Yes, what did you say, Mr. Twambo? Yeah. Perception. Colleagues, first, before I start saying yes, let me just, I'll need to verify some of these. Before I start saying yes to now, and then you come next time, sir, I put this answer and you said yes, I've got it wrong. For now, just remember price, your income, and your preferences. I think perception can also fall under preferences, but perception is, yeah, perception is it's a very paramount fact. So this question here, it's saying, oh, question one says, explain the term total utility. So here in economics, we measure satisfaction, colleagues. Okay, did you know that you can measure satisfaction? In economics, we measure satisfaction in utils. Okay, utils. So utility means satisfaction. When you hear the word utility, just equate it to satisfaction. Okay. So total utility is just your total satisfaction. Okay. From consuming a good, basically. Another important term is marginal utility. Can anyone give a try? What is marginal utility? Additional satisfaction. In economics, when you hear marginal, just think of additional or extra, okay? Additional or extra. Marginal utility is the additional satisfaction. As you are going to see, I think in question 4, we'll be tabulating marginal utilities. Okay, so more this will be explained in the final question there. Part B is assume a consumer's budget has intercepts 20 for good Y and 30 for good X. The price of good X, Px equals 10. Determine the consumer's income and determine the price of good Y. Now, colleagues, remember when we looked at the budget constraint equation? The budget constraint equation is like this. Okay, M is your income, Px is the price of good X, this big X is the quantity of good X, Py is the price of good Y, and Y is the quantity of good Y. This is the original format of a budget constraint equation. Now, here in this question, we've been given the intercepts. So what the intercepts basically are telling us is that if this person just buys only good Y, they only buy 20 units of good Y. And what the x-intercept is telling us is that if this person only buys good X, they are only going to can only manage to buy 30 units of good X. All right. So how you get these intercepts? X-intercept equals your income over the price of good X. Okay, your income over the price of good X. So we've already been given our x-intercept of 30. We do not know our income. We already know the price of good X. I think it was what? 10. So to get your income, M equals 30 times 10, 300. So your income is 300 kwacha. Okay. If income is 300 kwacha and good X costs 30 kwacha, okay? So if you spend that 300 only on good X, spend that 300 kwacha on, or the price of good X is 10, yeah. So if you spend all your income on buying good X, 300 divided by 10, you'll be only able to get 30 units over good X. Any questions? Very easy, right, colleagues? You can even answer this even though. Mhm. Here it is. X-intercept equals the income over the price of good X. The price of good X is 10 kwacha. The X-intercept is 30. So I want to find the income. So you cross multiply. So X equals 3 times 10. So your income equals 300 kwacha. Is that okay, sir? X-intercept is just income over the price of good X. Both. Okay, okay. Thank you for noticing that, sir. Any questions? Is this consumer friendly? Mr. Twambo, is this consumer friendly? Mr. Vincent, Mr. Dennis? So now we need to get price of good Y. Okay, so Y intercept is just your income over the price of good Y. Okay, so our y-intercept has already been given to us. It's been 20. It's 20. So it's just telling us when we spend all our money on buying good Y, we can only buy 20 units of good Y. Our income is 300 kwacha. So we need to find the price of good Y. So you cross multiply. So 20 times PY, 20 PY, 300 times 1, 300. So to get the value of PY, 300 divided by 20, 15 years. Yes. So yeah, and that's how that question ends. Determine consumer's income. One, what is PY? Oh, colleagues, this question, this one here, for there was the last part here. For part B, what would the effect of a rise in price have in the total revenue? This one, part B, where we got our PED was 0.58, and we found that demand was inelastic. And we found that this good is also a normal good. So, what if price increased since demand is inelastic? What will happen to total revenue? Mm-hmm. Before I type it out here, since demand is inelastic, if you increase the price, what will happen to total revenue? It will increase. It will increase. Okay. You want to write down the sentence? Have you got it down, Mr. Twambo? Mm-hmm. Mm-hmm. Yes, sir. It's a promise. Okay, okay. No, I was put at gunpoint for this class, so that's how it just came. Okay, okay, okay. That Mr. Foster? Okay. Okay, okay. Did we do we haven't done production theory? Yes, it's in the group. Yes, in the videos. It's in there. I'll look for it. I'll repost it even. Okay, so part C, from the following total utility schedule. So here, what this utility schedule is telling us is this. Okay, let's see. This top row represents the number of units you consume for the good. Okay. This bottom unit here is giving us your total utility. When you eat 1 unit of this good, your satisfaction is 4 utils. When you eat 2 units, your satisfaction is 14 utils. When you eat 3 units, your satisfaction is 20 utils. When you eat 4 units, your satisfaction is 24 utils. When you eat 5 units, 26 utils. 6 units. So here, have you seen? As you continue eating the good, your satisfaction is first increasing. But there will be a point where your satisfaction will stop increasing at 0.5 here. Okay. And the more you eat of this good, your satisfaction is going to now start reducing. Basically, you have become tired of the good. Okay. So here, they've told us derive the marginal utility schedule. Basically, they ask you derive the additional satisfaction you get for eating each good, each unit of the good. Okay. So your table will be like this: number of units, utility, Okay, so the formula that we'll be using here to get our marginal utility, this is the formula. Marginal utility, which is the additional satisfaction you get when you consume an extra good. Okay, it's the change in utility divided by the change in consumption or change in the number of units consumed. So basically, this is your new satisfaction U2 minus your old satisfaction U1 over your new consumption C2 minus your old consumption C1. Okay. So if we start here, marginal utility. Here at 0 units, there is no marginal utility. Okay. So here at 0 units, you're going to be at you won't put any amount. Now, when you move from 0 to 1 unit, okay, your old utility U1 is 0. Your U utility, which is 4, you'll say it's U2. Then for the consumption, C1, this consumption was 0. Then C2, your new consumption is 1 unit. So basically, you're going to say marginal utility 4 minus 0, because we move from 0 utils to 4 utils. Then consumption is going to be 1 minus 0, because we're not consuming anything at first. Now we're consuming 1. So you're going to say 4 minus 0, that is 4. 1 minus 0, that is 1. So your marginal utility is 4. E. Marginal utility is 4. Any questions? Okay, you did 4 minus 0 divided by 1 minus 0. That's how you get 4. Are we okay with this? Consumer friendly? Is this consumer friendly? Any questions before we move to the next part? Okay, so the next part now we're focusing on when we move from eating 1 unit to eating 2 units. Okay, so our U1, which was our initial satisfaction, was 4. Our U2, which is our new satisfaction, is 14. So on this part, U minus U2 minus U1, it's 14 minus 4. Then below for our consumption, we're now consuming 2 units from 1 unit. So 2 minus 1, that is 1. 14 minus 4, that is 10. 10 divided by 1, that is 1. So here our additional satisfaction is 10 when we move from 1 unit to 2 units. Are we okay with this, colleagues? Can we try to get our new additional satisfaction when we move from 2 units to 3 units? Can we try this one? Get your U2 and your U1. Get your C1 and your C2. Six, that is correct. We just did 20 minus 14, 6. Divided by 3 minus 2, that is 1. So 6 divided by 1, that is 6. Okay, can we get the next one when we move now from 3 units to 4 units? Get your U2 and your U1 and your C2 and your C1. 4, yes. 24 minus 20, that is 4. 4 minus 3, that is 1. So 4 divided by 1, that is 4. So now, colleagues, notice this, okay? For changing consumption, it's always going to be 1, as you can see, because I'm moving from 1 to 2, then 2 to 3, and 3 to 4. So your changing consumption is just going to be always 1. Okay, so in an exam, you don't even need to do all of those tabulations. You just subtract the utilities like this. Okay, so your marginal utility for here, you just have 4 minus 0 here, that is 4. Marginal utility for 2 units, 14 minus 4, that is 10. Marginal utility for 3 units, 20 minus 14, this is 6 units. Marginal utility for 4 units, just do 24 minus 20, that is 4. Okay. For 5 units, what's the additional satisfaction? If we use the shortcut method, 2, yes. 26 minus 24. Because you know, in your denominator, it's always 1. Then for at 6 units, what's the additional satisfaction? Yes, 0. And then for 7 units, what's the additional satisfaction? Yes. Any questions, colleagues? So what this is basically telling us is when you start first, when you consume 1 unit, the satisfaction is 4, and the additional satisfaction basically is going to be 4 utils. When you move from 1 unit to 2 units, okay, the additional satisfaction is now 10. When you move to 2, from 2 to 3 units, the additional satisfaction that you're getting is 6. Because here, this is just representing the additional satisfaction from the good, the new amount you're eating. Okay. And you're going to notice something about the marginal utility. Have you seen? It increases, then starts to drop. Have you seen from 4 to 10? Then now it starts to drop continuously. Okay. And notice as it continues dropping, eventually even your total utility starts to drop eventually. So this is what we call the law of diminishing marginal returns. The law of diminishing marginal returns, which basically says as you consume more of one good, eventually the additional satisfaction will reduce. Okay, that's the law of diminishing marginal utility. As you consume more of one good, eventually the additional satisfaction is going to reduce. Okay, so we'll plot this graph part 2 here. But part three, where it says determine where the law of diminishing marginal utility begins to operate. Where the additional satisfaction starts to reduce. Here at 3 units. Mm-hmm. Yes. So the law of diminishing marginal utility begins here, where the marginal utility starts to drop. Okay. At first, it increased from nothing to 4, then 10, then now it begins to drop. So this is where the law of diminishing marginal utility begins. Okay. Always look for the place where marginal utility starts to drop. Okay. Then this part here, the saturation point, where there's no more satisfaction that you can get, is here, where marginal utility is 0. So where marginal utility is 0, it means there will be no more additional satisfaction you'll be getting further on. So that's the saturation point, where mu equals 0. Yes, so this is your graph here. X-axis number of units, y-axis marginal utility. So as you can see, first it increases and starts to reduce. Yes. Any questions? Is it fair to say good night? Where the marginal utility starts to drop. Okay. Mhm. That's the saturation point where the marginal utility is 0. Yes, so that you can shine in your group meetings. No, no, no. This document is for a special group. There's a special group, sir. This one's for a special group where I'm making sure I'm putting. I'm sending it definitely. Actually, let me even.